Hi everybody, I'm just making this video so we can talk a little bit about how to favor SN2 products. So as we've kind of seen by now, you can get a whole bunch of products that you don't want. And if you just want a straightforward substitution reaction, you kind of have to play the game a little bit to make sure that you end up with what you want and not a whole bunch of E2 products or something. So the way that people generally do this is they use a nucleophile that's a bad base. Okay, so a lot of the nucleophiles that we've seen so far can also be pretty good bases. So you have to look pretty carefully to find something that has localized electron density. Okay, that's going to give us the good nucleophile part. It has to be easily accessible. And then to make it a bad base, we need to have a stable conjugate base. Okay, so generally we're looking for compounds that are conjugate bases of very acidic acids. Okay, so if it's very acidic, that means that negative charge, that conjugate base, is going to be very, very stable. So if we look at some of the conjugate bases that we've worked with so far, these are some of the ones that we've seen, and some of them we've experienced more than others. There's a couple of new ones on here. But if we think about kind of any of things like HI, HBr, HCl, right? Those are all very, very strong acids, right? So they are strong acids because we're totally fine losing that proton and then getting to these conjugate bases. Okay, so we know that because they're so acidic, these are very, very weak bases. But since they got a localized negative charge, they're actually still pretty good nucleophiles. Okay, but you're not going to see like a bromide acting as a base, right? There's very certain few occasions that you can, but this is kind of what I mean by good nucleophile, localized charge, got a negative on it, lots of electron density, very accessible, but very, very bad base. Okay, and that's going to be the same for all of these. So all of these you can kind of imagine came from their acid counterparts here. Okay, so we have something like that. For the acetate, we would have it come from a carboxylic acid, right? The thiol would be SH2, HCN, and some sort of sulfide or thiol. So these are all pretty acidic, whether through resonance or just what atom they're on or whatever. They're pretty acidic, but that leads to a pretty non-basic conjugate base, but still has that localized charge. Okay, so anything in this list, if you use that as a nucleophile, if you just like throw sodium chloride at it, right, that is going to give you an SN2 only reaction. Okay, because if we think about it, when we're looking at kind of an alkyl halide type situation, right, we're looking at the acidity of that proton. Now, it is fairly acidic because we're getting to a pretty stable conjugate base basically, but the acidity of this is all down to kind of induction, right? Because we've got an electronegative atom nearby. So it's not that acidic. So if we have a weak base, it's not going to do it. So let's look at a couple of examples here. Okay, so we've got the bromide there, and I'm going to throw a methyl group on over the side. So if I react that with sodium acetate, okay, and let's just say we're running this in acetic acid as just the solvent, okay? It's not too crazy. That's essentially the same as like if you use sodium ethoxide and ethanol, right? Okay, so we've got our strong nucleophile. It's going to go pop over to the carbon, kick the leaving group off. Since our bromine is in the back, our acetate's going to come from the front, making it be on a wedge. And now I've got my new product. Okay, this is the only product. Okay, as soon as I see this, I'm not even going to consider E2 reactions. I'm just going to go for the SN2. Even though this is a secondary alkyl halide, this is what's going to happen. Now, these still fall under the same rules in terms of like a tertiary alkyl halide. Okay, so if I have something like this, okay, if I've got that compound and I try to throw in sodium cyanide, there's basically going to be no reaction here. Okay, so the reason for that is the CN minus, isn't a good enough base for E2, but it's if I'm going by an SN2 mechanism, I still cannot do it on a tertiary alkyl halide. Okay, so we're still following the same rules in terms of, you know, making sure that we're not breaking the no tertiary alkyl halides for SN2 rule. But we can at least cut down E2 reactions from secondary alkyl halides and primary alkyl halides if that's something that we need. Okay, so again, as always, let me know if you have any questions, and I'll see you all later.